Hi, everyone. We're the activated carbon subteam for spring 2021. I'm Christopher.
I'm Samantha.
And I'm Nathan.
Next slide. Activated carbon's goal is to find a new and efficient way to implement the use of activated carbon before the flocculation unit process in order to improve the efficiency of agua clara water treatment plants. This research will expand the mission of providing safe water on tap because it is based off of a new design where both powdered activated carbon, PAC, as a filtrant and polyaluminum chloride, or PACL, as a coagulant would be used to remove particles. The reason that this area is being researched is because coagulant is not very efficient at binding to and removing organic materials such as humic acid in drinking water. Activated carbon as a material is used in many household drinking water filters and fish tank filters to remove harmful organic molecules in the filtration step of the water treatment process, and also to increase the clarity and potability of water. If this process that we're researching is found to be viable, it is important for the process to be scaled up so that it could be used in larger scale plants and not just in the lab setting. If the use of the mixture of activated carbon and polyaluminum chloride is found to be an efficient process, it would be able to revolutionize the efficiency of agua clara plants and be used further in other water treatment plants as well. Activated carbon is a relatively new subteam, and therefore there are minimal previous works to build upon. However, in this research, humic acids will be used as a contaminant because it is in organic compounds that the coagulant has trouble removing in the first place. It also has a brown color to it, and therefore ultraviolet spectrophotometry, in addition to turbidity, may be used to determine the clarity of the water. Therefore, the activated carbon subteam is building on the work of the humic acid subteam by using the values of the optimal coagulant dosage that the humic acid subteam has found previously. The values of wavelength and maximum absorbance of humic acid will also be used to construct a calibration curve and use data from a spectrophotometer. This subteam is essentially branching from what humic acid has been working on and using a new type of flocculation system to find an optimal coagulant dosage and powdered activation carbon dosage. Next slide.
So as Chris said, in the spring of 2020, activated carbon was introduced as a new subteam that focused on using powdered activated carbon to increase the efficiency of agua clara's water treatment plants. Activated carbon built upon the fall 2017 and spring 2018 humic acid subteam's work and used the optimal dosage of 5 milligrams per liter and 10 milligrams per liter of humic acid. It was discovered by the spring 2019 humic acid subteam that flocks formed using coagulant only were too small to be able to form a flock blanket, which made the effluent water's absorbance value higher than anticipated. Therefore, they decided that their main goal was to determine whether activated carbon was a better method for removing humic acid in water with no clay in it. However, due to COVID-19, the team, along with the rest of the student body, was kicked off campus and forced to stop their research. The previous activated carbon subteam started their experiments by only adding powdered activated carbon and polyaluminum chloride to the system in order to observe the effects of the carbon inside of the sedimentation tube. After that, humic acid was then added into the system with powdered activated carbon at a constant dose while varying the polyaluminum chloride to determine the optimal dosage to add to the system. A summary of the setup above: the turbidimeter goes through the flocculator to produce flocks and is then put through the sedimentation tube, which forms a flock blanket, and the output of the sedimentation tube goes through another turbidimeter and a spectrophotometer, where it then goes to the effluent. Due to the College of Engineering taking 3 months to build a sink in our lab space, the work that we did this semester transitioned from performing experiments in lab to doing research and prepping for when we were finally granted access to the lab space, which was just this past weekend. This work involved reading a ton of research papers to get us more familiar with the topic of activated carbon, as well as on both the Python and Procoda code that we will use immediately going into lab. Next slide.
So far this semester, we have planned our baseline experiment to find the optimal amount of coagulant that we will use to create flocks when there are high levels of humic acids and other organic substances in the water. In order to plan out the baseline experiment, we wrote the necessary Python code to calculate the values in the table on this slide. We also wrote our Procoda method file for when our experiment is due to begin. And although we did gain lab access in Hollister B55 towards the end of the semester, many materials were missing, and as a result, we were unable to actually start our experiment. We were, however, able to familiarize ourselves with parts of the lab and with the equipment that was there at the time.
So the future tasks that the future members of the sub-team will have to do mainly involves all of the lab work that we were not able to do this semester. These tasks include the one listed in the slide, building up the setup inside of the lab and running the experiments to collect the data. Once this is done, progress will be made, and hopefully our overarching goal of implementing activated carbon into current agua clara water treatment plants will be fulfilled. Other potential tasks that sub-team members can do would be ways to research and improve and innovate the system, which would potentially involve incorporating a recycle system for contaminated activated carbon. Thank you guys so much and have a great summer.